We're all working on long range with low power use, but with low bandwidth. So how can we squeeze as much payload in there as possible? That will be the topic of the next talk. He's the lead IoT R&D engineer at My Devices, which is an IoT solutions company. We're going to broaden up to more IoT devices in this round. Ladies and gentlemen, please welcome Erik Ptak.
Thank you.
Point it over there.
Okay, thank you. Hi, everyone. So I'm Erik Ptak. I work at My Devices, and at My Devices we are providing IoT solution and IoT platform. I'm in charge of supporting new devices and allow the platform to support as much as possible as devices. And over the last year, we integrated about 200 devices, 200 LoRa devices. So I thought it would be nice to discuss with you some payload format for the LPWAN such as LoRa application. Next, doesn't work. That way, okay. So most of the time, everything starts with an ID. And let's take a simple use case. Today, let's build a device to monitor fridge using LoRa. Pretty simple, but there is some stuff to deal with. First thing to do is to define the device requirement. So, as I said, we want to monitor a fridge. So, for example, we put a temperature sensor, we need the humidity, we need to monitor as well if the door is open or closed. And then we need to monitor the device itself, so the device battery. And we need to make sure that the battery will at least last for X years, let's say 10 or whatever. What we are interested in is to send the sensors data, eventually to send base data, to receive commands, to receive configuration, and eventually we need to define the human interface for the device. Is there some buttons, some screen, some sound, and the case. Once you define all the requirements for your device, we come to some specifications. So on the specifications, there is several steps. First of all, the RF design. For that, you have the Semtex design rules, design guidelines. Then we need to define the electronic design, the mechanical design, and finally the embedded software. And the embedded software depends on all the above, so the RF, the electronics, the buttons, the sensors, everything. And what we are interested in today is the data transmission. There is obviously a lot of stuff that we need to specify, but that's some example. For the data transmission, we already have the LoRaWAN specification that provide the overall architecture, such as the device, the gateway, the LoRa network server, the joint server, and so on, up to the application layer. We have a lot of regulations that we need to take care in the LoRaWAN specification with the different regions to define what frequency we'll use, what are the bandwidths, what are the limitations. A lot of stuff usually with the regulation. The LoRaWAN also take care of the device identification, the data integrity, the security, the privacy, a lot of stuff that tell you or when to send data and how to manage your data link, your transmission. But there is something missing today, is how do I format my sensor data to send it to a cloud platform, for example. And we have a lot of solution possible. So let's take easy as first, a JSON. JSON is something very common today in internet application, web and mobile. It's human readable, it's convenient for use with web application, it's smaller than XML most of the time, and also there is no data order. It means that once you parse a JSON, you can just read whatever attribute you want at any time. The point is that it extensively uses string buffers to build the JSON, to parse it, and at the end, if we look, it takes, in that example, so with our temperature, with our humidity, battery, and door sensor, it will take, for example, 96 bytes, which is a bit too much for a LoRa link. Definitely. And to me, it doesn't fit very well the embedded system needs. So we can definitely lower it down. For example, we can replace temperature, humidity, battery, all the attribute key by just a letter, so THBD, and we lower the size for about 30 bits, but that's not enough. Let's go further. CSV file or CSV format, basically using some separator. It's definitely smaller than a JSON. It's human readable still. And you will need to use some delimiter. So here I put some columns, but it could be a comma, it could be whatever, a slash, a dash. But the point here is that we need to understand is that there is a data order. Once you do your parsing, you will split all the elements, and here the first element will always be the temperature, the second will always be the humidity, and so on. Same, it uses some string buffer to generate the payload, but as we can see, it's about 20 bytes in that case, so that's not a big deal. It's something that we can manage, but we can even go lower. Let's strip everything and make it a raw binary payload. So that's the smallest payload that we can have, definitely. Also the simplest format. It's not human readable, unfortunately, but it's very easy to use, it's very easy to build, it's very easy to parse, and also the good thing is that the size of the payload will be fixed. It will be always the same size. But same as the CSV, we need to take care of the data order, and there is no unit meaning. So let's take an example. I want to express 2.5 degrees Celsius. There is a small trick also that you can do. Instead of using a full floating point number on 32 bits, you can just use 16 bits and use some fixed decimal. Here, we are going to store the data in tenths of degrees. So for 2.5 degrees Celsius, we just store 25. And once we decode, we divide. On one we encode, we multiply. For the humidity here, 40%, it's just a single byte. Same for the battery, and same for the door status. So we come to 5 bytes in that example, which is really small, very efficient, and that fits very well the embedded system. The only problem is that, as I said, there is no unit meaning, and you need to know in advance, when you will want to integrate that in an application layer, what is the order, and you need to know what is the format, or how I can describe, basically, the data format. How I will know that the first byte will be a temperature, or so on. You will maybe think about the LoRaWAN frame port. This is something that exists, that could be used to define some stuff, but the LoRaWAN frame port is free of use, at least from 1 to 23. There is no enforcement on that, and it's more application and device specific. That means for a given payload format, you will have a set of LoRaWAN frame ports that are used, but you can have some collision. For example, you could have 2 devices that are sending different data format on the same port. And so you cannot use a frame port to filter data and assume what will be the data format. Instead, we need to use something different and to make the format to describe itself. A good option is protocol buffers. Maybe you are aware of that. Protocol buffers is based on some descriptor file, a proto file. You can see an example on the right. So here I defined a sensor message with all the temperature, a humidity, a battery, and a door information. The equal 0 are not the meaning of the default value. They are subtype of the integer 32. It's just from the language of protocol buffer. It uses low-level types, such as integers, floating point, and stuff like that. But the good point is that it will use some dynamic data storage. The payload will be bigger as the data inside is bigger. For example, here, with my temperature, what was 2.5, so 25, for example, it just needs 1 byte to store. So if we look on the example, we have the 08 19, sorry. The 08 defines the, it's actually a prefix for protocol buffer to know what is the data type behind, what is the data behind. And 25, it only needs 1 byte. If it was like 2000, it would need 2 bytes. So the payload will raise as the data need more space. Simple as that. But similar to the raw payload, there is no unique meaning. It's just int, so it could be whatever. And you will need on the application layer to define by yourself, is it a temperature, what is the unit, and so on. So maybe we can do something better, but the good point is that with protocol buffer, it's a bit more size than the raw payload, 8 byte in that case. It could be a bit bigger, but that's fine. I mean, it's something that we can manage quite easily. So after we integrate at my devices a lot of devices, we started to think about our own payload, because sometimes people, some manufacturers were coming to us and were saying, okay, how should I send data? And we are struggling at the beginning because we hadn't a proper payload format. And we came with some proposal that people, some manufacturers integrated today, about 15 of them. The Cayenne LPP payload is a dynamic structure that self-describes itself. Each data is prefixed by a sensor ID and a type. And the type are based on the IPSO Smart Object Guidelines. IPSO Smart Object Guidelines define a lot of data types that exist, such as temperature, illuminance, actuator, and stuff like that. And we just take the same object ID to reuse in Cayenne LPP payload. So we don't redefine all the data types, we just reuse something that exists already. If we take an example here of the payload, so the part on the left is just for the temperature. O1 will define the sensor identifier, so here just one, the first sensor of my device. The second part will define the data type, so here 67 is for temperature as a Celsius value. And then the value, as before, I took the same rules. I save actually 25, which I divide by 10 to get the 2.5. The next block is for my second sensor. It will be the sensor number 2, obviously, and we'll give it a humidity and so on. You will tell me what are we providing number 1, number 2, number 3, number 4 if we just choose the data order? Well, that's the point, is that we don't need to make sure the data order will be the same across all frames if Cayenne LPP payload. And if we want to split the payload in several parts, for example, at one time just send the humidity, at one time send the temperature, at another time send all together, we can do that with Cayenne LPP payload because we identify the sensor by itself with an identifier and the data type. On the side, it's a bit bigger than the previous example with protocol buffer, 14 bytes. That's not a big deal. That's still manageable. There is other option. If we want to go further, for example, SNML. SNML is a payload format that is part of the IETF core working group, and it has been written to be used over XML, JSON, or XI. And XI is an efficient XML format, a binary one. It comes either from a XML or a JSON, but to move from the human readable to the binary one, we need an XSD descriptor. I didn't show it here, but that's a big one, bigger than the protocol buffer to me. So we can see an example as an XML. I didn't put the binary form of that sample with just a single temperature value, but just that single temperature value in the binary form, it will take 15 bytes. That's too big for me compared to protocol buffer. The good point is that it's unit-based. As you can see, it shows degrees Celsius. And this is a good thing for an application to know what is the unit of the value for help processing and to show it properly and to make some alert based on that. So much bigger than protocol buffer. To me, that's a good candidate, but maybe not for LoRaWAN application. The last one, or one of the last big one, is Zigbee Cluster Library. Zigbee Cluster Library, or ZCL, is a client-server model with read, write, request, response. So it's quite complicated. You first need to send a request to the device to read some attribute on a given cluster, basically, and it will return the value. So the good thing is that ZCL defines a full set of clusters, temperature, humidity, actuator, and stuff like that, with a lot of attributes as well, minimum, maximum, current value, and so on. There is some work in the Alliance today, it's almost done, to adapt the ZCL stack into some LoRaWAN frame. The intent to do that is just to transition existing ZCL device to LoRaWAN, so either to change the module or to use some gateway in the middle, some ZCL to LoRaWAN gateway. That could be an option too. It's also good to know that there is already some manufacturers that are using ZCL, not the full stack of ZCL, just the application stack with the cluster definitions, with the attributes definitions, and the basic payload. I didn't show any example, but it's a bit bigger. If we summarize a bit what I showed to you until now, well, what we can see is that the raw format is very simple, but it's very easy to use, it's very small, so we could think that's a good one, at least for the embedded system part. Now, what about the application layer in the cloud or whatever? Let's use a device, a LoRa device, to monitor fridge. Let's not build it, let's use it. And actually, I'll make it short. It's pretty simple as an application layer. It doesn't matter. A JSON, a CSV, a raw format, protocol buffer, Cayenne LPP, SNML, ZCL. We have all the power we need, all the language, all the frameworks, all the SDK we want to properly decode and support those formats. So you could think that the raw format is a good option, but I don't think so. What's the deal? Well, there is some concern is that, as I show, you need to know what is the format. We need to know what is the order, for example, with the raw payload. Where is the temperature? Where is the humidity? Where is the door? And so on. And let's assume that you are doing 2, 3, 5 devices using raw payload format with different sensors. It will mean 1, 2, 3 integration. And so this is not scalable. More you want to integrate devices, and more you will need a common format. Otherwise, every time we integrate a new device, it will be a totally new integration. So, instead of using a raw format, we could use protocol buffer, but same thing. Every time we want to support a new device, we need to push the new proto file. With Cayenne LPP, SNML, or ZCL, it's self-describing. So, as long as your application supports those formats, you can connect any device to your platform. You will support it out of the box. You will be able to process the data, to display the data, and do whatever you want with the data. Now, as a service maker, so I show mainly as a device manufacturer that will want to build a device. I quickly show as an application provider or developer that will integrate a device. Now, let's assume that you want to do both. You want to build a device that will connect to some LoRa network, and you want also to build the application layer that will decode the data. That's a bit more complicated to me, because you will need to integrate all the LNS you want your device to be supported with. That's the first point. Then you need to decode the data, so you are responsible for that, so you should be able to do that. You need to provide an application. That's not a big deal too. But then you need to provide all the APIs to access that data through your server. And it's not a difficult if we are used to provide API, but really integrate all the LNS. Today, there is about 20, maybe more network servers in the world. And so if you want your device to run on all the network, every place, you need to support all the network servers. And you need to follow up on that network server. OK, so I'll give you some recommendation on the payload format. The first thing is not rush at all. Think for future extension, think for future use of your device. And mostly, please, avoid text-based formats such as JSON, CSV, and so on. I will notice another funny fact is some manufacturer just send a next string of their message. So a string, but a next one. Instead of just sending binary data, they format the binary data into a next string and send it to a frame. That doesn't make sense. Also avoid the per model format. Try to combine your device into a single format as much as possible, and also identify your data in your payload. That's the most critical point. Either put an identifier to say that's the temperature, that's the humidity, that's the door, or give a type of your value. So it will be much better for you to integrate then new device, to support new device, and to make everything. And last thing, a prototype payload is not a production one. That's important, and you need to understand that your payload can change over the time as your product life cycle go up. You can improve your payload. Just avoid to make any big change after you move to production. And actually, we got the same reflection at my devices. We released Cayenne LPP 1 year ago, and we are going to release Cayenne LPP version 2, which is more industrial. It has a lot of frame port definition with some specific use. The sensor ID, if you remind, I show number 1, number 2, number 3. If all the sensors are already in the same order, we don't need that sensor ID, so I'll make it optional. There is also a full GPS dedicated frame port with a full scale resolution for GPS latitude, longitude, and altitude. That was some feedback I had in the past. Historical data support as well. You will be able to send data from in the past, actually, and also configuration command. You can send command to your device to let them to tell him send me data each 15 minutes, for example, or reboot, thing like that. A lot of new features, and the contribution I'll welcome. You can find the QR code that bind to our community forum, to the LoRa section. I posted a message, I think it was yesterday, with the first extract of Cayenne LPP version 2. And feel free to put some ID, or if you have any concern or have any ID. Today we already have 50 manufacturers that are using Cayenne LPP, either for the dev kit or production device. So that's OK. Thank you. Thank you very much. We have a booth. Feel free to come see you, my devices. Over there, we are doing demos, workshops with some pretty cool stuff.
There will also be a workshop with my devices. When will it be and where it will be about?
Yeah.
When?
Today, all the day.
Today?
Today and tomorrow and maybe Saturday.
Okay.
Yes, Saturday. Well, I got the confirmation.
Okay, thank you. Well, thank you very much, Erik. I host a lot of IT conferences, and normally bandwidth is no problem because it's infinite. And here, it's very limited, which is obvious at LoRaWAN, but you use a lot of creativity to squeeze as much as possible into it. So it's very interesting for me as a relative outsider.
Thank you.
Any questions for Erik? Oh, here at the front, yes. Hello. Who are you?
I'm Daniel. I'm an independent consultant. I have a question. Why didn't you choose some like an existing standard such as ASN1 or something like this?
So it has been a choice just after looking over the different standards and also getting the feedback from the different manufacturers. It came from here, and after we integrated a lot of devices, we tried to find a combination that could fit everything. So that's why we come to that. It's just by choice.
Thank you.
Yes. Other questions or comments, remarks, philosophical theories, algorithms, anything you want to share with us? 3, 2, 1, last call. No, thank you very much. And thank you, Erik Ptak.
Thank you very much.